Today's problem, we have a 3 kilogram box sits on an inclined plane, which is 25 degrees, and is being pulled by another 7 kilogram box, which is pulling at 90 degrees. Friction on the inclined plane is 0.10, and the 7 kilogram box is elevated 2 meters. And the question is asking us to find the final velocity of the 7 kilogram box before it hits the ground and the time it takes to get to that velocity. So let's draw a diagram. So here we have our right triangle inclined plane and our 3 kilogram box and our little pulley system here, and the 7 kilogram box is elevated 2 meters. So we have to break this one right here down into its vertical and its horizontal forces. So this one is going to be mg sine theta, because that's the only, so I'm going to draw this mg1 as well because that's the force of gravity acting on the box, and its horizontal gravity, which is mg cos theta right there. And this one is 90 degrees, and there's no horizontal forces acting on it, it's only going downward, so I'm just going to call this mg sine theta. I'm going to call m1, so this is going to be 3 times 9.8 times sine 25, that's right there. So m1g cos theta, that's the horizontal position, that is 3 times 9.8 times cos 25. And here we have for m2, this is what we call this the mass 2, 7 times 9.8 times sine 90, and we're just going to call this 1 because sine 90 is just 1. So m1g sine theta is going to be 12.42. M1g cos theta is going to be 26.65, and m2g sine theta is going to be 68.6, or just m2g. So now let's calculate the friction. So the force of friction is going to be the friction coefficient times the normal force. But in this case, the normal force, or just the horizontal force, the other horizontal force is acting on this box is mg cos theta. So we're just going to call this the force of friction, which is 0.10 times our mg cos theta value right here, which is 26.65. That's 2.665. So let's calculate the net forces. We have this one, 68.6, minus this one right here, 12.42, minus our friction, obviously, 2.665. Hi, future Paul here. I forgot to mention that we don't use mg cos theta in the net forces calculation because we're actually trying to find the acceleration of the downwards position for the 7 kilogram box. So the horizontal acceleration on this thing would not matter in this situation. So yeah, that's just a little notice. Equals the total masses, which is going to be 10 times A. We're going to get 53.51. So 53.51 equals 10A. Let's just divide 10 by both sides. You're going to get an acceleration value of 5.31 meters seconds squared as our acceleration. So now to find the final velocity, we have to use the equation v squared equals u squared plus 2as. Now, u squared in this situation is just our initial velocity, which we can just cancel out because it is 0. So we have v squared equals 2as, so we're just going to root both sides. So this is going to turn into v equals root of 2as, and our velocity here is 2 times our acceleration, 5.351, and our initial height, so that's just at 2. Okay, so we're going to get a velocity value of 4.62 meters per second. Finally, now to find the time it takes to get to this velocity value, we're just going to use the equation, our velocity here equals at, and to find this t, we're just going to divide a by both sides. So now we get this equation, v equals a over t. So we have our velocity value at 4.62 over our acceleration value, which is 5.351 equals t. So yeah, for this problem here, it's going to take the 7 kilogram box to reach 4.62 meters per second in 0.86 seconds. So yeah, thank you for watching. Please like and subscribe.